Assalamualaikum and good morning everyone. Today we are going to present about the engineering application of thermodynamics in induction cookers. So we are from group 1 and our group consists of 3 members and firstly I would like to introduce myself. My name is Muhammad Hazim Abdul Rahman. The second one is Divesh Anak Lelaki Makendran, and lastly Ahmad Izzat bin Azmi. So without further ado, let's start. Okay, so now we are going to talk about the introduction, and the first part that we are going to talk is about the description of induction cooker. So induction cookers have been used widely in the entire world. It is not a new technology. It is already been using in recent few years. They do not need flames or direct heat or to heat food. Basically, it is all about the science of induction, where the heat is created from the strong electric fields. Okay, because of that, cooking will be more efficient than using conventional methods such as using gas stove. Okay, induction cookers is categorized as an open system. Why? It is because the heat and water vapor produced are often lost to the air. An open system, as we know, can exchange both matter and energy that is present with its surroundings. Okay, so next, what is the benefit of using induction cookers? Okay, first, we can have a safer workplace. It is because the lack of direct heat allows consumers to touch the cooker top or surface without any effects. Second is, it is easy to clean. The surface of induction cookers is built flat, which makes it easier to clean. And lastly, they have faster reaction. The induction cookers will react quicker and more precisely when controlling the dial up and or down, since the heat is generated inside the cookware.
Hi, my name is Divesh Makindred and my matrix number is 200345. I'll be presenting the part of the first law of thermodynamics. So what is the first law of thermodynamics? So basically, energy cannot be created or destroyed, but it can change form from one form to another. So the total amount of matter and energy remains constant. The conservation of energy is equals to change of U equals to Q minus W. Change of U is the internal energy, Q is the heat, and W is the work done. Okay, so electrical energy will be supplied from the power source to the coil of the induction cooker. So from there onwards, the coil will produce magnetic field that will interact with the base of the pan to produce heat, which is transferred to the pan through radiation. So once the pan is heated up, the substance in the pan will absorb the heat through conduction and go through the cooking process. So that is basically the first law.
Hi, my name is Ahmad Izzat bin Azli, and my matrix number is 207850. So I will be presenting on the second law of thermodynamics. So does our engineering equipment relates to the second law of thermodynamics? Firstly, in general, the second law of thermodynamics is a spontaneous process of energy that moves from a region of higher temperature to a lower temperature. The law also states that the entropy of an isolated system never decreases. This is due to the isolated system spontaneous evolve toward thermodynamic equilibrium. For our engineering equipment, which is the induction cooker, the copper coil beneath the stove of induction cooker will act as the hot region, while the kitchen utensils, which is the pan, will act as the cool region or as the surroundings. So when the equipment is switched on, heat will be produced by the induction cooker. So how does this heat produce? When the current flows inside through the copper coils, a magnetic current is created, and the resistance of the materials converts the electrical energy into thermal energy. So during this process, there is difference in temperature between both of the copper coil and the pan. This will make it achieve a state of equilibrium. All in all, the working process of induction cookers follows the principle of second law of thermodynamics.
Hi, now I will present the part of description of parts in the induction cooker. Okay, I will just basically tell like the function. So inside the induction cooker there are 12 parts. So 8 minor parts and 4 major parts. So these 8 minor parts acts as a shield and control panel to protect the four major parts. So the four major parts are basically coil plate, IC plate, fan motor, and inner shell. The eight minor parts are microcrystal glass plate, plastic sticker, bar, body shell control plate, bottom plate, power cord, and rubber foot. Okay, so I will tell the function now. Okay, so for the microcrystal glass plate, it protects the induction cooker from getting any damage. Plastic sticker, it protects panel from water spillage. So the bar acts as a connector between plate and the body shell. So it's basically connects it. So the control plate, it switch on and off. It acts as a switch which we can on and off, and also we can use the control plate to like control the heat to for our desired cooking state lah. Desired cooking state. Okay, then coil plate, it passes electrical current to produce magnetic field to the coil. Body shell, main parts inside the cooker are placed and protected there. So that is the use of the body shell. Okay, then the IC plate, it control power supply to the coil. While fan motor prevent damages to internal components of the cooker. Okay, then inner shell, it is the base to hold the IC plate and fan motor. So it's basically quite important to protect the IC plate and also the fan motor because it's one of the major part. Okay, then bottom plate cover the gap of the cooker, and then power cord, it supplies electricity for the cooker so that the cooker can work. Okay, then last but not least is the rubber foot, which protect the household from getting current shock when for example when the cooker is not working, so it will spill the current. So the rubber foot will hold the current from going out to the household and prevent us from getting the shock.
Okay, next let's move on to the next part, which is working mechanism. So how it works? Firstly, all we need is a cookware which is made of ferromagnetic material, which is such as stainless steel or iron. So the controller on the cooker exerts an alternating current through the coil. The coil normally made of copper. Third, magnetic field is then created above the coil from the current flow. And fourth, the current alternates back and forth together with the magnetic field. Fifth, if a pan is placed on the surface, the magnetic field induces an electrical current in the metal base of the pan. Six, as the magnetic field alternates, the current flows back and forth. Seven, the metal will resist this flow, and at this time the heat is created. And lastly, the food in the pan will absorb the heat. Okay, now we are going to talk about the analysis and calculation. Okay, as you can see in the picture, it is a boiling kettle represents energy in motion. Water vapor is produced from the water when the transfer of heat occurred from the induction cooker to the kettle. As a result, work is done. To analyze how heat transfer is changed into doing work, it is important to recall about the conservation of energy principle. The conservation of energy principle to systems applied in the first law of thermodynamics, showing that heat transfer and doing work are the methods of transferring energy into and out of the system. The law also states that the change in internal energy of a system equals the difference of net heat transfer into the system with the net work done by the system. The first law of thermodynamics also can be seen as in the equation delta U equals to Q minus W, which is delta U is the change in internal energy of the system, Q is the heat transferred into the system, and W is the net work done by the system. To understand better on how to think about the internal energy of a system, we can examine a system going from state 1 to state 2.
In conclusion, a lot of everyday kitchen devices use the principle of thermodynamics. For our equipment, which is the induction cooker, converts electrical energy to heat energy, which follow the first law of thermodynamics. The equipment also transfers heat energy from a hot region, which is the copper coil inside it, to a cold region, which is to the pan. Uh, this shows that the induction cookers follows both of the first law and second law of thermodynamics. That is all from us. Thank you.